Martin Jetpack. The first useful jetpack in history was the Martin Jetpack. The very first basic jetpack is a single-person aerial vertical takeoff and landing technology that is simple, adaptable, lightweight, and easy to use. It may be used for emergency response, recreational activities, and security surveillance. A fail-safe jetpack that may be deployed as low as 6 meters is one of the pilot safety measures. With a 5,000-foot flying limit, a 100-kilogram lift capacity, an hour and 30 minutes of operation, and a top speed of 100, it is powered by a gasoline-powered internal combustion engine. Its twin-ducted fans, powered by a gasoline engine designed specifically for lifting the aircraft and the pilot during vertical takeoff and landing, provide the push needed for longer flying times. TAM Rocket Belt. As a rocket pack for the U.S. Army, Bell Aerosystems started developing what it later named the Bell Rocket Belt, or Man Rocket, in the middle of 1950. These packs can provide a strong, controlled push, which is why the idea was reintroduced in the 1990s. The vapor of water that has been superheated powers this rocket belt. 2 cylinders containing hydrogen peroxide that has been concentrated and a gas cylinder containing nitrogen gas are present. It was decided to use a rocket motor with 280 pounds of thrust. The load weighed 57 kilograms when it comprised gasoline. Fuel and nitrogen cylinders were mounted onto a fiberglass frame that was molded to the operator's precise form. The right lever of the device controlled thrust, and the hinged assembly that secured the motor was controlled by a regulator assembly connected to the throttle handle. Yves Rossi's Jet Wing Pack. Yves Rossi, a Swiss ex-military and commercial pilot, invented the Jet Wing Pack. It combines inflexible airplane-style wing panels with 4 miniature jet engines, each measuring around 2.4 meters. Although 2 jet turbines were originally planned, 4 engines were finally installed. Because of its carbon fiber wing construction, the wing pack can only take off vertically, thus, it must be launched from an airplane or helicopter. Kerosene powers the wing pack's jet engines. The force produced by the propulsion system enables an average speed of 200 kilometers per hour. Skyflash. With a jetpack intended to sprint down a runway before taking off, a German designer is attempting to achieve new heights. This may seem like a prescription for disaster, or at the very least, an ambulance to the hospital. Fritz Unger was inspired by the brave Felix Baumgartner and wants to mount 2 jet engines and wings on his back to enable him to soar like a bird. The overall total weight is around 55 pounds, with the wood wings weighing approximately 9 pounds apiece. Bending the outer sections of the wings may provide lift. Kitty Hawk Flyer. The jetpack was designed under the Federal Aviation Administration's ultralight category. Among the rules the engineers had to stick to was building a jet that could carry a single passenger without a pilot's license. The aircraft may only be used for recreational or sporting purposes, and its maximum weight is 114 kilograms. Because the aircraft is an eVTOL and its batteries are heavy, these constraints are significant to the engineers who designed it. The aircraft's range will diminish as its weight grows. It's fascinating to recall that some of the engineers gained valuable design expertise from their time spent flying this aircraft. Maverick Jetpack. The hands-free operation of the jetpack enables users to perform safer takeoffs and precise landings on difficult-to-reach objects, such as wind turbines, military hardware, buildings, and construction sites. The control system may activate an integrated autopilot to allow the pilot to multitask while in flight if needed. The Jetpack is designed to be used as a remote-controlled heavy-lift drone. According to Maverick Aviation, it can carry up to 10 times the payload of similar-sized devices that are now available. Aluminum, carbon fiber, titanium, and other lightweight materials were 3D printed to create the Jetpack. It will go at a speed of 10 to 30 miles per hour. Flyboard Air. If you compare the Flyboard Air hoverboard with Marty McFly's powered skateboard, it's just an accessory. It is the smallest jet-powered plane in the world. One hand may be used to operate it as well. Driven by 5 jet turbines, the jet-powered hoverboard, which the business names the Independent Propulsion Unit, can reach a maximum speed of roughly 110 miles per hour and fly for almost 10 minutes at a height of 10,000 feet. The weight restriction for the jet is 250 pounds. GB-10 Jetpack. A jetpack with 2 jet engines connected is the famous GB-10 Jetpack. The latest model can climb at a pace of 305 meters per minute and has 7% more power than the GB-9. The duration of each ride is 5 to 10 minutes. Iron Man. The maker claims that the Jetpack is propelled by 5 gas turbine jet engines with a combined power of around 1,000 horsepower. Even with gasoline inside, it weighs around 75 pounds. Diesel, kerosene, or jet fuel might power the jet. By moving their arms as they would if they were sitting on a surface, users may control the Jetpack. It has a maximum speed of 80 miles per hour and a maximum altitude of 12,000 feet. The Jetpack has only been tested at lower altitudes, the manufacturer pointed out, due to safety concerns. Hoverboard. Hoverboard ties are attached to both ends of the main tube to secure the pilot's feet. 4 permanent, curved legs that are fastened to the ends of the main wing tube make up the landing gear. Underneath the main tube frame are the batteries connected. Based just on visuals, we determined that the Prototype 2 hoverboard is about 2.5 meters tall. The prototype's safety barrier shields the pilot from harm and prevents particles in flight from getting in their face, from complex circuitry to carbon fiber to his own accelerator. The aircraft can resist being submerged in water and will continue to function until its next trip. While the designer has not disclosed how he manages the aircraft's orientation, Prototype 2's flight control might be as simple as adjusting his weight on the chassis.